we're looking at this reaction between barium hydroxide and hydrochloric acid, and we know that in the end we're going to create some moles of H2O, but we're trying to figure out how much of the energy of the enthalpy was sort of distributed to those moles through this ratio. So we have to first set up the equation, so BaOH2, and then that's going to combine with two HCl's in order to form the barium chloride plus 2 waters. Now we're also given a certain amount of each one of these reagents, so let's make that conversion. 0.07 liters times the molarity, 0.3 moles, divided by 1 liter. This is for the barium. And then over here we kind of have something similar, 0.07 liters times 0.6 mole over the 1 liter, and this is for the hydrochloric acid. If we did the math there, we should be able to get 0.021 moles on this side and 0.042 moles on that side. So if we look at the ratios here, it's a 1-to-2 ratio. That'll actually work out perfectly. And then when we come out here, we're actually going to be ending up with like a 2 ratio. So it would be 0.042 moles of H2O being produced in the end of this equation. So we got to kind of keep that in mind. Because we kind of have the bottom side here already. So now we have to just figure out what the H of the reaction is, and we should be able to figure this out. In order to do that, we should use the coffee cup calorimeter equation. So we have the Rxn is going to be equal to M times the heat capacity of the solution that we have in here. So we're trying to find the mass of the solution that we're going to put in there, and then we're going to basically convert that to grams and stuff. But let's see. So we have 4.184 joules divided by grams times Celsius. We actually know the temperature change here is 4.09 degrees Celsius. And so the Celsius are going to cancel out, and all we need to do is figure out what the grams is of the solution. Well, we know that we've been adding 70 plus 70 milliliters. That gives us 140 milliliters. And we also know the density of the solution here, so we'll just convert that to grams real quick. So we'll go 1 milliliter equals 1 gram. So we actually have 140 grams. This is a pretty easy one. So yeah, so the 140 is going to go right here. That'll cancel out with that. And so now we're just going to be left with the joules on top. We should have solved this at this point. We're going to go, this is times, by the way. So it's 140 times 4184, and then times 4.09. So we kind of have 2,395.76 or something as far as the Rxn goes. But we also know that the temperature change was a positive change, meaning that this was an exothermic reaction. And so the delta H for an exothermic reaction is negative. And so that is going to be what we have on top. Now we're going to want to divide this by the 0.042 moles of H2O in order to get our answer here. So let's just go and divide that by 0.042. So basically negative 57 kilojoules per mole of H2O. And so that would be the answer right there.